So today we are looking at what's known as power functions. Now we've already seen some power functions before.
Have we?
We have. So power functions. Alright, so power function are functions of the form y equals x to the n. So parabolas, x to the power 2, cubics, x to the power 3, and so on, they're all power functions. Alright, so in this particular case at the moment, what we're going to do is restrict ourselves to what n can be, and we're going to restrict ourselves where n is a positive integer. So 2, 3, 4, 5, 6 and so on is what we are looking at. Alright, so first of all, there's two different things that we can look at positive integers. We can look at if n is odd, or if n is even. So we'll look at n is odd. So n is odd, things like, already mentioned, x cubed, x to the 5th, and so on. Alright, so what do we know about x cubed? X cubed, what can you tell me about x cubed?
It has a point of
Inflection, yep. Correct. Byron says
yeah.
this. So it has a point of inflection here. Any other things? When x is 1, y is
-1. No,
positive 1. When x is -1, y is negative 1. I haven't drawn that all that great, but anyway. So it goes something like this. Actually, it's probably made that bit steep, this bit over here. That's probably a bit better. Now, what about x to the 5? What difference, or what things might be the same about x to the 5 as for x to the power of 3? Same shape, yep, or very similar, yep. What else? Same point of inflection, yep, 0, 0, yep. What about these points, 1, 1? What's 1 to the power of 5? So it still goes through here. -1 to the power of 5 would be -1. And we've got our point of inflection here. Alright, so it's the same basic shape, but x to the 5 would be a bit like this. So it gets a little bit steeper in there, a little bit flatter with the point of inflection. And then a bit steeper after that. Alright, so common features. So common features are, we've got our stationary point of inflection. At 0, 0. We've got, it passes through. One, 1, and -1, -1. And the other thing that we can say is as n gets bigger, that power gets bigger, gets flatter around here, around the point of inflection, and steeper after these points 1, 1, and excuse me, -1, -1. I can't quite squeeze that in there, so I'll put it over here. So, as n gets bigger, it's flatter around the point of inflection, POI. Can we cope with POI?
Oh yeah.
That'll do. And steeper when x is greater than 1 or x is less than -1. Okay, and our usual transformations occur. So we have transformations as we expect. So, for example, here's an example with some transformations. All right. So with this here, we've got a 3 up here, so it's a cubic. So that means it's like this one here, x cubed. But we've got some stuff that's been done to it. So if we look in order, what have we got? So here's the x. What happens here?
Translation to the positive x.
Alright, translation to, oops, 1
unit.
in positive x direction of 1 unit. Yep.
Sorry, no. A reflection.
The reflection
In
in the x. And then finally, translation
in positive y direction.
2 units in positive y direction. Right, so if we're going to sketch this one, there's some things we know about it. Now, if it's been translated twice, so what does that now mean about our point of inflection? Where is our point of inflection going to be? So these two things, when we put them together, they then tell us that our point of inflection will be where?
1, 2.
1, 2. Yep. So our point of inflection then is going to be here at 1, 2. We've then got a reflection, it's been reflected in the x-axis as well. So what does that mean about the shape? Where is it going to start?
Y.
It's going to go this way, yeah?
Yeah.
So if it goes this way, it's going to cross through the y-axis and the x-axis. So we need significant points. So our y-intercept, x equals 0. So y equals negative 0 minus 1 squared plus 2. 0 minus 1. Negative 1. Hey? Oh, cubed. I'd have put a square there. Ozzy, you should have. That's better.
Thank you.
Negative 1 cubed is
Negative 1.
negative 1. And then we've got a negative 1, a negative outside that negative 1, which makes it a positive. So our y-intercept then is at 3. Right there like that. Alright, our x-intercept, I'm going to put my labels on, occurs when y equals 0, so we'll go 0 equals the negative outside of x minus 1 cubed plus 2. Take 2 from both sides. Divide negative 1 both sides. Cubed root both sides. Add 1 both sides. So the x-intercept is at 1 plus the square root, cubed root, 1 plus the cubed root of 2. And 1 plus the cubed root of 2. About 2.25 according to the calculator. So it's about there. We can get away with that without worrying too much about it if we just label that point as 1 plus the cubed root of 2 and 0. So all we need to do is have it round about. And then drawing it up. Anything about that that I need to clarify for anyone? No. Another example.
Just a question.
Yep.
You labeled 1 plus 3 root 2 and then 0 as well.
Yeah.
Do you have to include 0? Can you just label it as 1 plus 3 root 2?
Yeah, that's a good question. Probably for completeness you would put the point as that. But yeah, what you're saying is right. It's this here, isn't it? That's
In the book, it
just puts the 1
okay.
plus the cube root of 2.
It does the same that you did, but
Yeah, right.
I was just asking.
Yeah, I suppose to be complete, you should do that. And so to be complete, I really should go 0 and 3 there as well, if that's the point, the actual point that it goes through, rather than just the axis intercept. The point that it goes through has 2 coordinates. So I suppose it's more complete when you do that. But yeah, otherwise we all know what it means. But all right, so let's have a look at another one where we might say look for an image. So this question's asked us to find the image. Of y equals x to the 5 under the following. Transformations. So first of all, we've got a reflection in the y-axis. Then we have a dilation. Factor 2 from y-axis. And then we've got 2 translations. Two units positive x 3 units. Positive y. Alright, so this sort of question in multiple choice exams, not uncommon to have this kind of thing. Which of the following could be the image of that under the following blah blah blah. Then they might give you a graph or they might give you equations. Alright, so what I am going to do is, because we're less familiar with the mapping, I'm going to use the mapping method. So with the mapping method, we come from our original. So from our original, x and y, we then do something. What are we doing? We're reflection in the y-axis. So with the mapping we need to think, what happens when we reflect in the y-axis? What changes? X changes and becomes negative. So x changes to become negative. There's our first thing. We then dilate factor 2 from the y-axis. So if we're moving from the y-axis, what changes? The x. And how much does the x change? By a factor of 2, which means we times. And we've already got a minus there, so now we've got minus 2x and y. Right, I'm going to do the last two together. So translation, 2 units in the positive x direction. So if we're in the positive x direction, what changes? The x or the y? The x, and it changes by adding 2. Alright, we're moving it. So if here's our point, and we're translating it 2 units in the positive x direction, we're moving it that way 2 units. So we're adding 2. Alright, and the y, if we're moving that up 3, we're adding 3. Okay. So, what do we know? So this is now here, this is our image. So that's our image of x and that's our image of y. So we know that our image of x is equal to minus 2x plus 2, and our image of y is y plus 3. Here's our original, y equals x plus 5, so this is the original y and the original x. So with our mapping, we will need to replace our originals by something which has the image in it. So we need to rearrange this to get x by itself, and the same here with the y. Alright, so if I take 2, I get that. If I then divide by negative 2, I get that. And with the take 3 there, and now with the mapping method, I now replace this x by this stuff, and I replace this y simplify this stuff for my mapping method. So when I do that, I've got y dash minus 3 equals okay, so I'm replacing x by all of this stuff, and here remember the x is being to the power of 5. So we've got x dashed minus 2 over negative 2. Alright, that's probably not how the answer might be. So remember, if it's a multiple choice question, the answer could be written in any form. Right? Could be like this, could be like that, could be like something else. All right, so what can we do with this? We can go, okay, the image minus 3 equals, if I split that up, I've got that. Negative 2 to the power of 5 is? It is negative. Negative what?
No.
32. Negative. Alright, so multiple choice question. Could have that. Could have that. Could have this. Or could have this. Alright, so multiple choice question could have various different versions on there.
Groovy.
So your multiple choice questions, just if you get an answer, just because the way you've got it written, they may or may not have that there. If they don't have that, don't just jump straight to the conclusion you've made an error. Have a look, see whether there could be a different version. All right, now of course once we've found our image, we don't need to put our little image marks on there just to help us when we do the working so we don't get confused. Alright, so there's the odd powers. Let's look at the even powers now. Alright, even powers. X squared, x to the 4, and so on. So if I draw a graph, what can you tell me about x squared? Some points. It's a parabola. Some points. Turning point. Keep there.
1,
1,
1.
1.
Negative 1.
Negative 1, 1.
Negative 1, 1. So, yep. All right, what's for x to the 4? What's going to be the same about x to the 4?
It's going to be
be more.
Wider.
It's going to be more
Square.
square at the bottom, more square here. Yep. What about these 3 points? They're in the same, right? All right. So, as Byron said, I'll overemphasise me more squareness there. Like so. And so the bigger that number gets, the more steep here and the squarer at the bottom that it becomes. Alright, but all evens have that. Alright. So let's look at, I'll write them up over here, so squeeze in there, that gets a bit low down there. So what are our common features? Common features are our turning point. These points here. Yeah. So common features are turning point. At 0, 0. Pass through. 1, 1. And negative 1, 1. And as n gets bigger, it gets flatter near the turning point. And steeper when x is bigger than 1 or x is less than negative 1. Alright, let's do an example. So let's have a look at another kind of example. Alright, so equation example. Graph of y equals a bracket x minus h all to the power of 4 plus k. We're told it has a turning point at 2, 2 and passes through 0, 4. Find a, h and k, and it says hence find the equation. Now, normally on the exams they'll say hence or otherwise. I was just too lazy to write all of that. Hence or otherwise find the equation. So whenever they use the phrase hence or otherwise on the exams, what they're saying is what you've just done, use that to find the answer. They only put the or otherwise bit in is because there may be another way of doing it. And so if a student used the other way, they would still get the marks. That's the only reason it's there, but whenever they say that, hence or otherwise, what they're telling you really is the easiest way that you're going to be doing this is to use what you've just done. Alright, so if my turning point's at 2, 2, that means straight away I can write this equation as what? I don't know the A yet, but what do I know?
X and Y. No, sorry.
H and K.
H and K. So x minus 2 and plus 2. Now, I've got one other thing that I need to find out, and that's this A, this dilation, and I've been given this other bit of information. So what do I do with that?
You substitute it with what, x and y?
You substitute it. What a great idea. So 4 then would be equal to a times 0 minus 2 to the power of 4 plus 2. I'm going to take 2 from both sides to get 2 equals a times 0 minus 2 is
-2.
negative 2. So negative 2 to the power of 4. Negative 2 to the power of 4 is
16.
16.
Dang.
Divide both sides by 16. 2 over 16 is the same as
1/8.
1/8. So our equation then is y equals 1/8 x minus 2 to the 4 plus 2. Alright, anything else we need to clarify? You all good? I think so. Alright, exercise 3G questions. On your work plan. And don't forget, like and subscribe.